sorry. Now I'm going to talk about Prospective LCA, that is another application of LCA in the agri-food sector, specifically in food processing in this case study. This is the case study will be about industrial salmorejo production. I don't really know if you know what is salmorejo. It's like gazpacho andaluz, a kind of cold tomato soup from South Spain, but nowadays we eat everywhere, and even since the industrial processing of this product began, the exportation of these products to Europe, to Belgium, France, Germany, it's increasing and increasing. As you can see there, the recipe, more or less, it's an emulsion of tomato and olive oil. Then there is also garlic to increase the flavor, bread to give consistency, and then this topping with boiled egg and Spanish ham, jamón ibérico. And in fact, till the 1990, that the first industrial plant of gazpacho and salmorejo began. The production has been soaring, and this small plant increased, and then some years later, PepsiCo Group bought this plant, and now there are like 2 big factories of this product, but also many small or medium scale plants. Well, you can see here that last year the production was more than 100 million liters and the turnover was more than 200 million. In this kind of products, pasteurization is key to extending the shelf life, and in food technology in general, there are new pasteurization technologies, novel pasteurization technologies as radiofrequency. That, for instance, radiofrequency, because the heating is very fast, is supposed to be more sustainable and also to increase the product quality. By the moment, although radiofrequency is being applied to solid foods and also to liquid foods, there are no studies, scientific studies on the application of this technology to viscose homogenates that require meal pasteurization temperatures because they have a low pH. They are acid. And with this project, RF Susbec, it was a project funded by the Spanish government, and we studied the potential benefits, not only from the environmental and economic point of view, but also sensory, nutritional, safety, product shelf life, etc., of salmorejo process with conventional heating technologies, that is concentric tube heat exchanger, but also with continuous flow of radiofrequency processing. Then we were in charge of the environmental and economic study, and I'm going to show you the results of the LCA. So the goal was to carry out a prospective LCA of salmorejo pasteurized with radiofrequency, with a twofold goal. On the one hand, of course, to compare its environmental impacts with those of salmorejo processed with conventional pasteurization, and also to highlight the relevance. We wanted to highlight the relevance of upscaling with performing prospective LCAs. Well, here you can see some research question we wanted to answer, but I will show you later when I show you the results. And here in this figure, in this plot, you can see the temporal and technological status of each of the studied scenarios. Our departure point was a pilot plant, a pilot processing line that one of the partners of the project had, where they were performing all the experiments to know the process and the characteristics of the product and so on. So you can see that in this case, we can radiofrequency, it really exists. There are manufacturers of this equipment. And so the TRLs, the technological readiness level, is quite high. We consider it's 7, and the MRL is 8. And so when doing a prospective LCA, you have to take into account the time needed to develop. And we consider perhaps it was too much, but that in 15 years, this technology will be fully implemented. So our temporal framework was 2035. And then we made the upscaling at two industrial scales, medium and large scale. And we compared these two scales with the pilot results for the same time framework and also with the conventional processing. I have to say that because this conventional processing already exists and only the part of the thermal treatment is changing, there are less degrees of freedom, but there are less degrees of freedom. There are not so many things to be that we could change, but the reliability of the results can be more or less higher. Well, here you can see the functional unit, 1 kilogram of salmorejo packed in Tetra Pak. The previous studies of our partner show that there were no differences in the quality or the shelf life of the product. So the two products are really equivalent, and this meant that on the one hand, the reference flows are the same, but also they put some pressure on us because they expected that at least from the environmental point of view, the products show some differences. I will see what happens. And then we use two system boundaries, gate to gate and farm to factory gate. The temporal boundaries are those that I told you, 2035. And we made the upscaling from the pilot scale that processes 200 liters per hour to medium 4,000 liters per hour and large scale 2,000 liters per hour. Well, here you can see the background processes from these commercial databases that we all know. And we also had some sources to model the prospective electricity mix in the future, and also for the natural gas. Indeed, the natural gas combustion is going to be the same, but it's supposed that with time the leakage from the tubes, from the gasoducts will be lower. Here you can see the impact assessment methods we use. Here you can see, I hope you can see with this light color, the two processes, the pilot and industry plant. The main differences is that the washing of the tomatoes is made by hand, was made by hand in the pilot plant, but here no, in the industry. And also that these two operations are made in the same equipment at the industrial plant. And another big difference is that the preheating, even with the radio frequency, is made with heat exchangers, but in the industry, the pasteurized product is used to preheat the product entering in the process. Well, here, the first question we wanted to answer is how does upscaling affect the environmental impacts of radio frequency processing? Well, here we have the pilot, medium, and large scale, the same process with radio frequencies, and as expected, impacts are higher at pilot plant. The reasons, because the energy consumption is greater, because there is not heat recovery, and also I forgot to tell you that in the pilot plant they use an electric boiler, but in the large scale, industrial scale, natural gas is used as fuel in the boiling for thermal energy. And then main differences in pilot a medium scale, as you can see, the biggest differences, the greatest differences are in climate change, but it's 16% difference. Metal depletion and ozone depletion, 17 and 19%. And when we compare pilot with large scales, between medium and large scales, these differences are also around 17, 10, 8%, most of them. Well, the second question we wanted to answer is if there are relevant differences between radiofrequencies and conventional pasteurization with heat exchangers. Here you can see the results. And in this case, we observe that the differences were minor between the two pasteurization technologies. For instance, in the case of climate change, when using the conventional treatment, it's a slightly higher for the conventional. But when we look at, for instance, marine eutrophication, the radiofrequency has a slightly higher impact. The reason is that all the processes are the same and only the radiofrequency is changing. But this radiofrequency substitutes part of the thermal treatment and not the preheating, which is still made with by recovering the heat of the pasteurized product. Well, here we want to answer which units, processes, and life cycle stages most contribute to the impacts. And here you can see the contribution analysis of the pilot plant process. The yellow is the packaging. We saw it was very important, much more than the processing. The processing was important in water scarcity, with blue water scarcity. And also we can see that the landfill of the organic waste was important in some impact categories as climate change and metal depletion. But when we move to the industrial scale, we see that thermal treatment decreases because of this recovery. And in this case, we had the support of a company that makes industrial cleaning. So we optimize the cleaning in place system, and the share of the cleaning is much lower. And again, packaging and the landfill of the organic waste are the two stages impacting the more, depending on the impact category. When we consider the farm to factory gate system boundaries, we can see the relevancy of processing of salmorejo in the life cycle of the product. And in this case, as expected, tomato raw materials farming, agricultural stage of raw materials, especially that of tomato, that is the main ingredient, is makes the most significant contribution to the total impact, ahead of packaging and landfill. So in order to make proposals to reduce this impact, we made this scenario analysis with 18 scenarios in which we consider not only changes in the processing with conventional thermal treatment and radio frequency, but also we consider some scenarios using thermal energy from solar plant. And also we consider not only packaging in Tetra Pak, because it was so relevant, we also consider PET and recycled PET. I mean PET containing 60% of recycled material, and two end-of-life scenarios for the packaging. One with the conventional end-of-life, taking the averages treatment of packaging materials from Eurostat. And with the improved one, we consider that Tetra Pak was mainly recycled, and with the recycling rates for all the materials from the best ones from Eurostat. Well, we can see again that Tetra Pak, that is with red point, I mean, the scenarios using the brick, the Tetra Pak, are also the recycled PET, are the ones that presented the lowest environmental scores. But you can see that, for instance, I forgot to say that here we are assessing 5 impact categories because we found some statistical correlations between impact categories. And so we saw that only with these 5, it was enough. And I mean, Tetra Pak and the recycled PET were the best. The scenarios with these two materials were the best ones. Well, just to finish, as we all know, and if you have read some literature or you have some experience in prospective LCA, upscaling and temporal background changes are the most, give a lot of uncertainty to the results. But in our case, unfortunately, we didn't have so many data about for the upscaling of the process to do an uncertainty analysis that we have some experience in other projects. Now we are integrating the life cycle with the life cycle costing results in an eco-efficiency ratio using multi-criteria analysis, and we hope this will allow us to choose the best product design. And despite the uncertainties, we can say that the results of prospective LCA have a great value for decision makers and the developers of new products. So that's all, and thanks.
Thank you very much for your very interesting presentation. Any question from the audience?
No.
So I've got a question relative to the scale up. Did you have data both for the pilot plant and for the industrial plant?
No, only from the pilot. There was no producer involved.
Right.
So we were asking to machinery suppliers. For instance, the radio frequency equipment was from Italy, and the supplier gave us some data. That's all we had, but not a real plant, in part because they were not involved in the project, but also because of the pandemics and lockdown. And so we were trying to visit, and they say, no, it's not a good moment, and all this. Yeah.
So how did you pass from the pilot plant to the, how did you?
Well, using modeling and also the specifications of the machinery.
Okay. Right.
No question.
Okay, thank you very much then.